Welcome back. Today is day 7 of our Solving Quadratics unit. Today we'll continue to solve challenging problems involving perimeter and area. Just a reminder, a copy of the handout is provided in the description so you can follow along. Enjoy. To solve this problem, I'm going to do a 3 read on this one because again I have no picture and I only have just a word problem. So let's go ahead and read this thing out loud. So the first read is just to kind of see what is the problem talking about. So the owner of a ranch decides to enclose a rectangular region with 100 feet of fencing. To help the fencing cover more land, he plans to use one side of his barn as part of the enclosed region. What are the dimensions of the rectangular region if he wants to have an area of 2,000 square feet? Alright, so what I heard as I read this was that this farmer wants to have a rectangular region and he's going to use his barn. So that's gonna give us something that kind of nice. Oop, let's not use that. So let me draw in. So I'm going to say this is his barn. Okay, so that's the barn. And he's going to put some rectangular region on the side of that barn. So I'm going to draw that in another color. So this is the area, he might want to use it for, horses or something like that, or maybe he's planting something. All right, but okay, so this is the region that he's creating. Now what we should notice is that we only need 3 sides of fencing. We don't even need the 4th side because he's using the house or the barn's going to be the one side of the fencing. Alright, so now let's read this again, and now let's look for key information. So as I'm reading this, let's see what we got here. The owner of a ranch decides to enclose a rectangular region with 140 feet of fencing. So we know this is important. So I'm going to write that down on the side. So fencing equals 140 feet. Okay. To help the fencing cover more land, he plans to use one side of his barn. We got that already as part of the enclosed region. What are the dimensions of the rectangular region? So we want to find the dimensions. That's what we're looking for. Dimensions. That's ugly. That's what we want to find. We want to find out what are the dimensions. Alright. If he wants to have, and this part's important, so they're telling us that this area needs to be 2,000. Oh, that's not coming out nice. 2,000 square feet. Okay, so we know that the area of this barn needs to be that much. Alright, so what are we going to do here? So first thing I would do is I would try to figure out, okay, I need to know my dimensions. I need to find out what x and y are. So I'm just going to label that right now. So I'm going to say, alright, my dimensions, I'll call this one x. And since it's a rectangle, I know the opposite side is also x, so that side's x. And now we don't know the length of this region, so I'm going to call that y. So now, solving problems with 2 variables usually is tough, but let's see if we can write in an equation here that helps us out. So one thing I know, so I know that the total fencing is equal to 100 and, well, let me erase that before I do that. Let me write an equation. So total fencing can be found in this problem by adding my 3 sides together. So x plus x plus y. So that makes sense, correct? Your total fencing should be the sum of x plus y. And now if we substitute and simplify some things, we know my total fencing is going to be 140 feet. And this simplifies to 2x plus y. Now eventually, when we solve equations, we're going to want to have one variable. We'll only work with one variable, so let's solve this equation for y. So I'm just going to subtract 2x from both sides. That would leave me with 140. Subtract 2x is equal to y. Okay, so now we have a relationship right here for fencing. So I could say, if I wanted to, over here, this side is really equal to 140. That's the total amount of fencing. and then subtract the 2x or whatever the other two sides are. Alright, perfect. So this is what I have so far. This is key. And most of these problems you're going to have to do something like this. You're going to have to rewrite one variable in terms of the other one. So that's how we do that one. Now the next part, now we can use what we know about rectangles. Well, in this problem, what was the area? What's the area for a rectangle? So area is equal to, in this problem, I would just have to multiply whatever x times y is. Alright, so that's all I'd have to do in this problem. But we know some things. We know the area of the rectangle. So we know that the area of the rectangle is 2,000 square feet. And we have x. But we also know what y is now. We just solved for y. So y is this quantity, 140 minus 2x. Okay. And now we're like, oh, now this is looking like an equation that we can solve. So actually, we can actually solve this equation. So let's start solving this. Alright, so what would I do? I would probably distribute right here. So now I'm looking at this and I'll just say, you know what, I'm going to distribute. So I have 2,000 is equal to, ooh, it's not writing nicely, 140x subtract 2x squared. Perfect. I don't like that negative there, so I'm just going to multiply everything through by -1, and I'm going to rewrite this. So this is now going to be negative 2,000 is equal to negative 140x plus 2x squared. Now the reason I did that was because I don't want the 2x squared to be a negative. I want that to be a positive. So just one little easy step so you can do that. And let me move this thing down a little bit. Alright. And so now where are we at? I'm just going to rearrange this because I don't like the way it looks right now. So I'm going to change this real quick to be 2x squared subtract 140x is equal to negative 2,000. Perfect. And that should look familiar to you. That should be like, oh, that's a quadratic. I can solve this one by completing the square. We've been working on that for a while, so let's do that. Let me just remove this all the way here so I can start working here. So now I'm going to just rewrite this again. And this will now change to 2x squared subtract 140x. I'm leaving my space, and I'll subtract by 2,000. Now, what did we say earlier about completing the square? We can't complete the square if a is not 1. So I'm going to divide everything in this expression by 2. So I'll divide this by 2, this by 2, and divide this by 2. So this is going to become x squared. And it's not writing nicely right now. I don't know why not. X squared subtract 70x, little space there, equals negative 1,000. Perfect. Now let's complete the square real quick. Let's see what we get here. 70, divide 70 by 2 is 35, and 35 squared. What is 35 squared? Let me use my calculator real quick. That is 1,225. So I'll make sure I'll add that to both sides, 1,225. Alright, almost done with this. Almost done with this guy. So let's change this. Let's change this to completing the square form. So this is going to be x minus 35. And then on my other side of the equation, you get 225. And you should be able to finish this up, no problem. There should be no problem from here. Let's just take the square root of both sides. And we get two values. Remember, we get a plus and a minus. So we're left with x subtract 35 is equal to plus or minus, what is the square root of 225? Well, that's 15. Oh, that's beautiful. Looks like someone designed this problem for us. That way someone was nice to us. Alright. And real quick and easy, let's wrap this up. Add 35 to both sides, so we're going to get x is equal to 35 plus 15, plus or minus 15, which means I have two answers. What are my two answers? Well, what is 35 plus 15? Well, that's 50, so x is equal to 50. And then what is 35 subtract 15? Well, that's 20. So I have two answers. X is equal to 50 and to 20. That's a 50, sorry. It looks like a 30. But that's a 5. Make it a little bigger. Perfect. Alright, so we have two answers. Let's see if this problem still makes sense. Let's see what all that work, what do we do so far? So let me draw the barns again. So again, we had two sides of fencing, right? We didn't need the third side. We don't need this side because the barn's here. So we don't need that side. And what we said from earlier, let me just take a look at it. We said that the left and the right were x and the bottom was y. So let's do that. So x is 50 for one answer, so let's write it 50 over here. So we have one side as 50, and the other side would have to be 50. Now, how much total fencing did we have? We had 140 feet of fencing, so that means we have 40 left over. And now, what do you notice? What would the area of this rectangle be? What's 50 times 40? 2,000 square feet. Beautiful. So yes, the dimensions of this rectangle would be 50 by 40 by 50. We don't need the other side. Alright, but there's a second answer that works. Let's see. So again, this one would be a longer, skinnier. And again, we don't need the fourth side, so we don't need this side here. But the dimensions would be 20, so one side would be 20, the other side would be 20 also. And the bottom would be how long? So if that's 20 by 20, that's 40. We're left with 100. And what would the area of this rectangle be? So if we multiply that out, length times width, we should get 2,000 square feet. So what we found out was there's two ways. If we had 140 feet of fencing, there's two ways we could make the area of 2,000. One would be a 50 by 40 rectangle, the other one would be a 20 by 100 rectangle. And that uses all the fencing that we wanted, and it gives us an exact area of what we're looking for. Alright, try the next problem on your own. It's going to be a little bit different, but same idea, same concept. And then resume the video when you're ready to see the answer.